Hello everyone, I am here to show you how to filter data from our raw data sheet. So for example, I got here the professional quality of life of around, let me see here, of 189 respondents. So as you would see here, there is a column. Column A is the participant ID number. It contains the participant ID number. So it's a series from 1 to 189. And the second column is the data of the respondents by sex. So there are females and males, and then the third column is for age, and the D column is for the number of years of experience, and then the civil status. And then the next columns here indicates the scores for each item in the professional quality of life of the respondents. And here is now the summary column, the total score for the items that measure compassion satisfaction, and this is column AJ. And then for column AK, this is now uh, the the total score for the items that sum up the burnout items. And for the secondary trauma stress, it is listed down here in column AL, and the total professional quality of life is in dark green, highlighted in dark green cells. So that's the total scores for the overall professional quality of life. So in the assignment that I have given you, I asked you to separate the data for the males and females and test for significant difference between the males and females. So this is how to filter data, okay, for separate for the females and separate for the males using the sort and filter option here in the buttons above your worksheet. Okay, so first you will have to copy these columns because you're only after the burnout scores by sex. So what we'll do is copy data, participants, the number, ID, and sex. Copy all. And open another worksheet here. And I will paste it here. So I have all of the 189 respondents in this from this main worksheet. So this is now the main raw worksheet. Now, since the problem was to test for significant difference between the males and females in terms of burnout, I will copy the burnout column from here and paste this to this new worksheet here. Okay. Oh, mali. I have to paste as numbers. Okay. Um, and you would see that that the row 2 is vacant, so I have to delete it because there would be a problem later on if I will not delete the blank cells. So there is no more blank cells there. between row 1 and row 3. Next is I will now sort this data. So I will go up here in the sort and filter button, then click filter. You would see that the first row, it will show button down here. And since I would like to separate the males and the females, so Excel will sort the males. The males first. So I will uncheck females here. So lalabas siya. So it will only select all the males. Okay, so you would see that all the participants, male participants, will be showing up in our worksheet here. So what I will do is try to copy this. Copy. And I will try to paste it here on the same worksheet if it will. No, there seems to be a problem doing this. So I will try to do this on another worksheet, on a new worksheet. So I have opened sheet 6 and try to paste all. So I guess, let us see how many males. $30. Or 43. There are 42. There are 42 males. Okay, so I have copied them and pasted them here in the new worksheet. So I will label this as males. And I will copy the burnout scores of females. First, I would have to filter. I have to filter and it goes back to its original placement here. Then filter, I will select the females. Okay, so I have checked the females and there you go. All the female burnout scores are shown. So I'll just have to copy this. Control, copy. Let's try. And I will paste it here. Okay, so you see that there are more females than males. When you proceed with computing for t-test for independent samples, actually t-test allows for unequal number of samples. But in the case of, especially if it is, the groups have an equal number of samples, like this one, it is a must that we have to test for homogeneity of variance, although it's part of the process, because when groups are unequal, they have unequal number of samples. When the groups have an equal number of samples, there is a higher probability or a higher chance that the variances may not be homogeneous, which is one of the assumptions of t-test for independent samples. In the previous video on t-test for independent samples, I used the Excel data analysis tool to process t-test for independent samples. Now I will show you how to do this using the RealStat. Control M together, and you would see that this box, this menu box is open. I'll be testing for normality here by clicking descriptive statistics and normality, because first we have to, before proceeding with the t-test for independent samples, we have to check for the assumptions first. So one way, well, the first assumption is that data, the dependent variable should be measured at the IR scale. This one is met, that assumption is met. And distribution of both groups should be normal. So this one here, we will be testing using the Shapiro-Wilk and the Agostino-Pearson. Okay, so I will first be testing for normality of distribution of the male ones. So I have inputted, I have filled up the cells of the male scores here. And we have checked descriptive statistics. I will not check box plot with outliers. I will check Shapiro-Wilk, and I will choose a cell where I will put the output. Okay, so you would see that the kurtosis and the skewness value of the male participants is near 0. So it's 0.495 for the kurtosis, and skewness is 0.28. And the Shapiro-Wilk says that it is normal. Yes, it is normal. And even the Agostino-Pearson agrees that the data distribution for the male burnout scores is normal. Okay, so that is one way. Then I will press Control M again to test for normality for the female burnout scores. I will have here females. I will be highlighting the values of the female respondents for their burnout scores. And I will uncheck the box plot with outliers. And I will choose an output range within this worksheet. So I will just have it here, 02, and click OK. So normality, let's look at the kurtosis and skewness. The values are very small. Kurtosis is 0.06 and the skewness is 0.37. If in other standards, this kurtosis and skewness have not reached an absolute value of 2.0. So I would believe that this is still normal. And although Shapiro works says that no, it is not normal, however, the Agostino Pearson says yes, it is normal. So I would prefer to believe that the burnout scores of the female respondents is normal. So the assumption of normality of distribution between the male and female burnout scores is met. So both are follow a normal distribution. Then how about homogeneity of variance? Okay, to get the quotient between the variances of the male and female respondents, and if the absolute value is greater than 2, okay, then we may have to assume that homogeneity of variances is being violated. So let us try to check the homogeneity of variance. Okay, whenever you start to compute, you always start with an equal sign in your formula. So we get this sample variance for the males. So we have 38.35 and divide it by the sample variance for the female respondents, and that would be 26.16. Enter. There you go. So we have here 1.46 as the score for homogeneity. The ratio between the variances of the two groups is 1.46. It is not greater than 2. So therefore, we assume homogeneous variances. They have homogeneous variances. So we can proceed with testing. Okay, normality of distribution between groups. Okay. Dependent variable is continuous. Okay. Random selection. Okay. So we will proceed. All of these assumptions are met. Then we can proceed now with testing for testing our null hypothesis that there is no significant difference in between the male and female respondents. So that is our null hypothesis, and our alternative hypothesis says that there is a significant difference in burnout between the male and female respondents. So I will proceed to compute this using the real stat. Okay. Again, I'll press Control M together. And the default button here that would open is descriptive. So I will choose miscellaneous tools. And you would see here, first on the list is the t-test and non-parametric equivalence. So I will choose OK, click OK. And so here, the t-test, I will now fill in the input range for the males. I am now testing for significant difference between the male and female respondents. So we have here the males. I will be highlighting the male scores. That includes the headings. And for the females, I will now be filling in the data for the female scores, the female burnout scores. Your options, one sample t-test, two paired samples, two independent samples, test type t-test. I will check here the output range. I'll just use it here. I'll just use the same worksheet for the output. Okay, there you go. Would see that our hypothesis is non-directional. It is a two-tailed test. So we will use this and we will assume equal variances, and since the variances are homogeneous based on our testing of homogeneity of variance. We now assume, okay, so homogeneity of variance is met, so it's okay. So we assume that it is the variances of the two groups are homogeneous. The summary results, we have here the mean for the males. There are 42 males and the mean is 19.88 and the variance is 38. And for the females, there are 147 females and their mean score is 19.38. And the variance is 26.16. So we have here a Cohen's d of 0.09. And for the equal variances, since we have assumed that their variances are equal, so we choose this one here, this table here above and not this table below for the unequal variances. So we have here the t-test for assumed equal variances, and we choose the two-tailed data here because our hypothesis is two-tailed or non-directional. So we have here the t-test value of 0.53 with a degree of freedom of 187. The equivalent p-value of this t statistics is 0.59. So this is greater than, this p-value is greater than the alpha of 0.05. So therefore, the decision here is to say that to conclude that there is no significant difference between the male and female burnout scores. Okay? If there would have been a significant difference, then we would include in our report the effect size. And that would be reflected by the effect size, this column here. And Cohen's d, the effect difference would also be reflected in our report. But since there is no significant difference, well, the effect size, the reporting of effect size is not needed in the report of the results section. So that is how to use t-test how to perform t-test for independent samples using the real stat. Okay, so in this video, you have learned how to sort your data according to categories by using the sort and filter button, and then how to perform the testing of assumptions for descriptives for t-test for independent samples, and how to use the real stat for your t-test for independent samples. Okay, so that's it. I hope this has been clear with you.